Hello friends, welcome to TMRM Art YouTube channel, and today in this video I am going to give uh, a open book test on GATE EC 2026 paper. So here all the question I shall try to attempt within 3 hours of time. So here timer also will be visible in the screen, and if you want to um, give any suggestion or if any query, you can ask in comment box. So we are starting this video. Let's start. Okay, thank you. I'm starting the counter. First, here is a logarithmic question. So here it is given this one. We can write it. In this way. Then here log y 1 to the power n. Okay, here I have little typing mistake. Here it is p to the power n and y to the power this. So the power will become in the beginning. Now you can see n equal to 4. So option B it is coming. Next, this is the question given. P1 plus P2 plus P3 plus P10. We need to find out if P1 is the perimeter of the square. Sorry, Pk is the perimeter of the square and k is the length. Then we need to find out the value of Pk actually. Okay, so sorry, we need to find out this one, not Pk. Okay, so Pk equal to 4 into k, because k is the length of that like a single side of that square. So 4k will be the perimeter of those individual squares. Now p1 plus p2 plus p3 up to p10 will be first squares, each side is 1 unit, seconds it is 2 unit, like that it will goes on. Okay, so we can take 4 common, then 1 plus 2 plus 3, like that it will goes on up to 10. Now the formula is there, n into n plus 1 by 2, 10 into 10 plus 1 by 2. Okay, natural number summations formula, 5 into 11, so 20 and 11, 2 to 0 it is the answer, and it is matching with option D. Next, find the antonym of the word nocturnal. So nocturnal means it is like who is active at night. Okay, and diurnal means who is active at day. So the antonym means the opposite meaning, so it will be diurnal. Okay, moving on the next one. Okay, consider the two port network. Okay, two port it is as shown in the figure. So here we need to find out the ABCD. Okay, it is in the form like Z parameter. uh, so we can write Z parameter Z equal to this one and this one we need to add, so 2, and we need to write in this diagonal, and the remaining this diagonal it will be this one. Now v1 equal to 2i1 plus i2. Okay, and v2 is i1 plus 2i2. Okay, i1 plus 2i2. Now from here we can substitute this like this. I means we need to first find out I1 with respect to V2 and I2, because in the ABCD parameter only V2 I2 is there in the right side. So V1 equal to 2 into V2 minus 2I2 plus I2 समान equal to 2V2 minus 3I2. So ABCD parameter will be first this 2 and 3, then this 1 and 2. Okay, so I think it is matching with C option. B it will not match. A is equal to 2. Now we are seeing the B. So B is here 3. So this option also not matching. Only option C is matching, if I am not wrong. So answer is C. So we are also following the time here. It is already 8 minutes gone. Nearly 8 minutes. So we need to speed up. Tens complement of 47 whole 10 means base 10 equal to what? The nines complement first we can find out. Okay, like we first find out one's complement, then two's complement, like that. Similarly we can find out here first nines complement, then we can simply add 1. So for finding out nines complement we need to do like this. So the tens complement 52 plus 1 equal to 53. So option B it is matching. Now question number 6. So here this is the Boolean function it is given. Valid from a Boolean function we need to find out. Okay, so let's first here we can make the k-map of this function. So x w, here in the options w x y z, like that sequence is there. So wx we can make here w bar x bar, then means wx this side and this side yz. So y bar z bar, y bar z, yz, yz bar, w bar x, wx, wx bar. Now 0, then 2, then here it is 5, 7, 8, 10, then 11, 12, 13, sorry, here it is 13, 14, and then it is 15. Okay, now we can do this. This is one box, this is another box. Okay, now this is a pair. So like that we can do, and so what it is coming actually here, x bar, and here it is z bar, plus here it is x z plus w x and y. So any option is there, x bar, z bar, x z, w x y. I think option D is there. And another, it can be like I can pair with these two ones, and that time this will come w and y z bar. So option B it is coming. Now we can see here with the options, option C and option D, these two things are same, but x z and here there is difference, but we cannot find x z from these two. Okay, by visualizing we can able to see that. Similarly here x also this and this one second, this and this term, sorry, what is this going on? Okay, similarly this also we cannot find through k-map. Okay, so you are neglecting these two. So option B and D here options. Okay, time is going on, so you need to be fast. If the address of initial location is at for KB, find the correct one. Okay, so here the size difference is 256 KB, that means 22 to the power 8 into this is for K, this is for 256, and this is for byte, 1 byte means 8 bit. Okay, so there are in total 2 to the power 18, so we can write it like this, uh, 0 0 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1. There are 18 twos are there. You can, it's 18 ones are there. You can just check it. And now we are going to add with this. Okay, 0 0 0 0 0 0 0 0. Then it is 5 0 1 0 1. Then it is 0 0 1 0. Okay, so if you do it, you will get it like this. You can just calculate it from your own. Just simple binary addition it is, and this is the answer. Okay, now question number 8. Here it is a shift register is there, so which can shift the binary bit. Okay, just initial states are clear, and deep flip-flop. Okay, for the deep flip-flop, it is also clear. Ignore the delay of the XOR gate. Find the state of the shift register after fifth clock pulses. Okay, so fifth time we need to rotate. B6, B5, B4, B3, B2, B1, B0. Here you can see this. Okay, here the input is every time here as the one input of the XOR is 1, so we'll get the complemented output here. Suppose B7, so B7 bar it will go to B0. So if we consider it as I in, it will be B7 bar. B7 bar. Now initially clock is 0 and everything is clear, and it will be 1. Now first clock is there. Now what it will happen, it will shift in the left side. Okay, similarly it will shift this side again in the second, fourth, fifth. Similarly it will shift here. Similarly it will shift here, and then shift here. And the in value will be always 1 up to 5 clock at least, because B7 bar always we are getting 0, so the bar will be 1. So after 5 clock pulse it will be answer is B. You can check here. Okay, check with this. Okay, I am not writing these zeros. Now move to question number 9. Maximum value of the VO. We need to find out, this is maximum value, so we need to check both positive and negative cycles. Or plus IV UI cycle. First we can find out the I1. It will be 6 sin omega t minus 2 by, here is one resistance, here is one resistance, means 20 into 10 to the power 3. Now VO will be in the positive half cycle. This diode will be uh, open circuited, only this much there, so it will be VO will be 10 into 10 to the power 3 into 6 sine omega t minus 2 by 20 into 10 to the power 3 plus 2. Okay, also diodes voltage drop we are considering as 0, means ideal diode here, so it will be how much, let's see, 3 sine omega t plus 1. So VO maximum of sine or cos theta is 1, so it will be 4 volt. Similarly for negative half cycle, it will be this circuit will be open circuited because of this diode will be in reverse bias, and that this diode, okay, will be forward bias, means D2 will be forward bias, so D2 will be forward bias, so we can so VO will be simply minus 4 volt. So magnitude also it is 4 volt, we can say. So maximum VO maximum is 4 volt only, is the answer. So time also going on, as we are seeing here. Now question number 10. Find the magnitude of VO by Vin if R1 equal to R2, all are 50k ohm. So here negative terminal, their feedback is there. Okay, so we can consider here virtual ground concept, V plus equal to V minus equal to 0 volt. Now here we can apply the KCL or nodal, we can say 0 minus VB by R2 equal to 0. So here we will get VB equal to minus VI as R1 equal to R2. Now at node B, here again we can use the perform the nodal. So VB minus 0 by R2 plus VB by R2 plus VB minus 0 by equal to 0. Now what it will happen, VO equal to 2 VB, sorry 3 VB, and VO 3 VB, and VO equal to 3 into minus of VI, so VO by VI equal to minus 3, the magnitude will be 3 volt. Okay, sorry, it is unitless because it is voltage by voltage, so this is the answer. Next this one, okay, closed loop pole at this and find the value of K and alpha. Okay, for closed loop transfer function, always the characteristics equation will be, means characteristic equations left side will be always same as the multiplication of these poles. So like that we can write 3 minus j root 5 into s plus 3 minus j root 5. These two, if we solve, is plus 3 whole square minus 5 whole square. 6 is plus 9 minus 1 5 which is square plus 6 is plus 14. Also the characteristics equation, if we write here, s square plus 1 by s plus 1 s plus 2 plus 1 equal to 0, so will be s square 2s plus s plus 2 equal to 0 into plus 1 equal to 0, plus 3s plus, okay, sorry, um, here characteristic equation will be this, okay, 1 plus k into s plus alpha by s plus 1 to s plus 2 into 0 because this is the gain, but this is the another thing there in that path. Okay, so we need to multiply both. Sorry, I missed this. So it will be s square plus 3s plus 2 plus ks plus alpha k equal to 0. So here s square plus is common if we take, then 2 plus alpha k equal to 0. Now we can equal these two. 3 plus k equal to 6, so k equal to 3. 2 plus alpha k equal to 14 equal to alpha into 3 with alpha equal to 4. Alpha equal to 4. So k equal to 3 and alpha equal to 4. These are the answers. So time is going on very fast. We need to speed up. Now the value of k we need to find out for which the system is marginally stable. As it negative feedback, unit feedback, so characteristic equation is like this. So can directly do this. Okay, you can understand it. 1 plus ky into s plus 7 s plus 11 equal to 0. From here we are taking this. Okay, then s plus 7 plus k equal to 0. Now s cube plus 11 s square, then s square plus 77 is plus k equal to 0. it is 11s. Okay, we are multiplying this with this to get this. Now s2 plus 10s square plus to 0. Now this one will be 1. Oh, sorry. So it will be 177 18 k. Then it will be 18 into 77 minus k by 0 into k minus k by 18 k by 18 to 0. For marginally stable, just need to be 0 actually. So 18 to sk equal to 0. Okay. So k will be 1386. Okay, can calculate. This is the answer. Next question number 3. Here find the value of VO. The switch is closed if VO is X. The switch is closed if VO is X when the switch is opened. Okay. Okay, so here what it is telling, we are finding out the VO. Okay, when the switch is closed. But here one value it is given that VO will be X when the switch is opened. Okay. So X when it will be opened. So we need to find out the VO when it is closed. Okay, when it is closed, then we need to find out the switch is closed. So first let's find out this. Switch is open and it is inverting op-amp, not inverting, negative feedback is there. So V plus equal to minus equal to 1 volt. Now nodal minus mu by 3k equal to 0 plus 1 minus equal to 0. So in this case the one second, here 3. Okay, sorry for a mistake. Three plus 1 minus PO equal to 0. So here I have done one mistake. I have corrected it now. Now VO equal to 4. So we are told in this case VO will be X. So X equal to 4 volt. Okay, am I correct? Then 1 volt equal to X by 4. Okay, now when the switch is closed, that time this is just bypassed and sorted. So that time again if we use the nodal, plus 1 minus VO by 2 equal to 0, 1 plus 1 into 2, 1 minus VO equal to 0, VO equal to 3 volt, and 1 volt equal to X by 4. So X by 4, if we write, it is 3 by 4 X. It is matching with option B. Okay, now next question. Here the phasor we need to find out. So first of all, just little brief on phasor diagram. So phasor diagram helps us like how much current is lagging behind voltage or current is leading uh, with respect to voltage, because if in those cases we can predict it is a capacitive or inductive circuit and how much power is being lost. These things we can analyze. So phasors comes into picture, and in this question it is written inductance and capacitance is there. So for IC IL is also shown. Okay, ICIL. Assume that the phase is theta 1 plus theta 2 is 90 degree. Okay, 90 degree at frequency, this frequency is 159.5 kilohertz. Okay, what is the nearest integer value of this 2's multiplication? Now what are there in my hand? According to that, I can do one thing, that is tan's formula we know. First write down this tan theta 1 equal to xc by rc. Okay, these are the formulas. Later if you want I can discuss how like this is happening, but as of now just know this, just know this happened. So again tan, so theta 1 if we consider A, theta 2 if we consider B, tan A plus B equal to tan A plus tan B minus tan A tan B. Tan A plus B tan 90 degree equal to this, and then that will be infinite. So the denominator part 1 minus tan A tan B will be 0. So tan A into 10b equal to 1. Now it will be xc by rc into xl by rl equal to 1. Now xc into xl equal to rc into rl. So if we want to find out this, we can find out this only. Now what is xl? Xl equal to omega l. Omega is 2 pi f into l. L it is given 1 microhenry. So 2 pi into frequency, it is given to 159.15. It is in kilohertz. 10 to the power 3 into 10 to the power minus 6 Henry. So this much it will come nearly 10 to the power 6 radian per second, and 10 to the power minus 6 if we add, then it is 1. So now xc 1 by omega c. Okay, so it will be 1 by 10 to the power 6 into 10 to the power minus 6. Because omega we have already got earlier. Now CO capacitance also, it is 1 microfarad, so this will be also 1. So RC into RL equal to 1 into 1 equal to 1. Okay, so option A, it is matching. Okay, option A, it is matching. Now let's move on. Question number 15. Average power in load 1 kilo ohm under resonance is. Average power in load 1 kilo ohm under resonance is what? So under resonance we can calculate the power through resistance only, because the full current will flow through resistance only, if I am not wrong. If I am wrong, please comment it down. So now Vrms equal to 12 by root 2, and then power through that resistance, it will be Vrms square by that resistance. So if you want to know anything in details, you can comment. I can research it from different places, and I can easily explain you later. Okay, sorry, because as of now I'm just continuing with this. So you can write it like this also. Ms into 1 kilo. Again, this one, it will be 12 by root 2 whole square by 1 1k. So it will be if you calculate it, it will come this only. So please cross check it. This is the answer in milliwatt. Okay, milli comes from this kilo ohm. Now question number 16. If we move on, we have to find out Ys by us. Okay, that is the transfer function. Okay, it will be we know C Si minus whole inverse into B. So here this is C, this is B, this is A. Okay, now let's write down 625 psi Si, it will be S minus of A 4 to the plus 1.5 to the minus 4 S. Okay, now it is 20 B. So C comes first, then A, then B. Cab. 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 Okay. Then 1.5. 0.625. So if you do this operation, we will get if you want me to solve, I can solve it later, but I think you know this. First we need to find out adjoint, and then we need to divide it with the determinant. Okay, so it will come like this. This is the determinant part, and the adjoint part is plus 4, and then if we multiply it with this, it will be 1.5, 0.625. Okay, then just multiplication, it will be 2s plus 8. Okay, now if you multiply, it will come like this. Okay, if I will multiply, it will come like this. So this is the answer actually. I think options are missing in this question. I have missed to add options. So this is the answer. Find the value of Vg. You need to find out. Okay. So as we know here, gate and this part is drain is sorted. Okay. So here both the points voltages are same. VGS is Vg minus Vs. Here is grounded, so it is 0, so equal to Vg. Now Vg equal to again VDD minus ID into 1k ohm, and if ID is in milliampere, then you can write in simply ID. Okay, again. So VDD, it is given 5 volt, so you can write it like this. Okay, now the current equation, we can write this given Ux W by L VGS minus VTH whole square into 2 to 10 to the power minus 3. Okay. Cux W by L. Cux also there. Okay, so here VGS we can write VDD minus ID as VTH equal to 1 volt. As we have taken here ID in milliamperes, so we may just bypass this. So ID equal to VDD is 4 minus ID the whole square. Which are ID plus ID square. ID square minus 9 ID 16.0. So ID, if we calculate, we will get like this, means it equal to minus b plus minus root over b square minus 4 into a into c by 2 into a. So from here we will get these two values. Now our ID value cannot be this because we have earlier seen this one, or we can see this one. Okay, VG equal to 5 minus ID. So ID value should be this only 2.43, because if it is more than 5 then VG will be negative, and if VG will be negative then NMOS is off. Okay, if VG is minus V. Okay, yeah, so it will be 2.562 volt. Next, question number 18. Now F equal to not bar plus S1 bar S0 into 0 plus S1 S0 bar into 1 plus S1 S0 into Y. It's by Z bar to 1. is what z into 0 x z about to 1 x z into 1. Distributive law. Now find in the following CMOS circuit, find the Boolean output of Y. This is the pull up, this is the pull down. These are NMOS in parallel, these are PMOS in series. If NMOS is on, it will short the output with the ground, so output becomes 0. So using that concept to check. Okay, 0 0 0 1 1 0 1 1. AB 0, then PMOS will be on, so Y will and NMOS will be off, so I will be 1. Other cases, as A is 0, it is on, so output will become 0, again it is 0, again it is 0. So Y equal to A bar B bar, A plus B whole bar. Means A plus B whole bar, means it is NOR gate. Option C. Then comes to question number 20. JK flip-flop is there, connected with high logic. Input clock frequency is 10 cycle per second. Okay, the output Q frequency cycles per second. So characteristic equation of JK flip-flop, n plus 1 equal to J Qn bar plus K bar Qn. J Qn bar J Qn bar plus K bar Qn. J Qn bar plus K bar Qn. Okay. 1 into Qn bar plus K bar Qn 0 into equal to Qn bar. Okay. So here you can see, I think, okay, J and K is this is J and this is K. So all are 1, so 1 is 0. And Q and Q are this is Qn actually. Okay. and this you can say q n bar. So it is coming q n bar only. So next state is complement of the previous state. So flip-flop is working in toggle mode, so the mode number will be 2. So frequency, the output Q frequency will be f clock by the mod norm. It is 10 by 2, so 5 Hz. Answer. Now 1 hour completed and we have just completed only 20 questions. I think we need to speed up. I'm just taking drinks. I think it's like adventures. We are giving these tests at time. As an aspirant, it is obviously it should be considered as adventure only. Now, cutoff frequency in gigahertz. A T10 mode, if dimensions of the rectangular waveguide are this and this. So this is the length 0.28, this is the width 0.14 inch, and 1 inch equal to 2.54 into 10 to the power minus 2 m. 0.54 into the FC 10 equal to sorry, not 10, it is 10. So because T10 mode we are calculating, so it is C equal to 2 C by 2 m by a whole square plus n by b whole square, and here m equal to 1, n equal to c. So c by 2 into 1 by a. So it will be 3 into 10 to the power 8 by 2 into 0.28, okay, into okay, it is we need to convert it in meter. So 2.54 into 10 to the power minus 2. So it will come as this gigahertz. That's the answer. Now question number 22. Here h1, h2, h1x, h2x are linear time invariant. So overall system, it is how it is, like non-linear, linear and not variant, not time variant, linear and time variant. S is causal. So that we need to find out as all the blocks here we are seeing, these are linear. Okay. So as it is all the blocks are uh, time invariant, all the blocks are here linear, so the whole system is also linear and all the blocks here are time invariant, so the whole system it will be time invariant. Okay, if you want to see the solution like what is yn, you can simply do chat gpt. Okay, it will come, I think I'm not pretty sure, but comes nearly like this only. So these are linear and time not variant, so overall block is time not variant. So one thing we can add here, if it is squaring term is there, multiplication of signals like xt and yt, and sine, cos, log, exponential, and also absolute value means mod value is involved, or we are taking in the system or this system, then the overall system it will be time variant and not linear. It's not time variant, it will be not linear. So just put it in your mind. Now move on to next question. It's 23. Okay, here x, n, y, z are random variables. X and n are independent. X is uniformly distributed to -1, 1. N follows normal distribution. Okay, zero mean and unit variance. Zero mean unit variance. Now find the correlations between x and y and that of x and z. So we need to find out the correlation between x and y and that of x and z also. So correlation between x and y, it will be xy bar equal to x into x plus n whole bar. X into x plus n whole bar, so x square plus x n x into y. Y, so it is x into x plus n whole bar, so x square plus xn. As okay, this we can write, and here x square whole bar plus as x and n are independent, so we can write this to x bar n bar. Okay, and this value is 0 because here it is written 0 mean. Okay, Now we need to find out this x square value. So x square is the variance part. Okay, n bar is the mean of the n, so that is 0 given, so that's why this value is 0, means this value is 0, so it is only x square bar. Now x square bar, that is the variance. If we want to calculate like this, x square into that probability density function value 1 by 2, because it is distributed in between this, so it is value is 1 by 2 in between in this. Okay, because equal distribution, and area will be always 1, so to make the area always 1, magnitude should be half. 1 into half into 2 equal to 1. So probability distribution function magnitude is 1 by 2. So if you calculate it, it will become, as it is a even function, we're doing like this. Okay, hence xy whole bar, means correlation between x and y, is 1 by 3 plus 0, that is 1 by 3. So here if we have written y equal to x plus n, because in the question only it is given. Now similarly we need to find out in between x and z. And z it is given like this. As they are independent, I can write it separately, not an issue. I mean, when there is plus, then we can write it directly, and also if it is in the multiplication form, as it is independent, so we can write it like this. And now this mean value is 0, so it is simply x cube. So it will be integration -1 থেকে 1 -1 to 1 x cube half dx. Okay, so I think I am right here. It will become 4 1 -1, it will be 0. So answer here, it is matching with option B. Okay, 24. Here the real baseband signal is given as xt equal to this. Determine the bandwidth B such that 99% of the total energy is contained with the frequency range. Okay. So we need to find out the bandwidth. Okay, so that the 99% of the total energy is content within the frequency range. Okay. That is the bandwidth. So xt equal to t1 minus 2t, t greater than equal to 0. Now here omega equal to 2 plus j omega. Square plus 4 u1 equal to so energy is here. If we want to calculate, wait for just 30 seconds. I know I can do it. 1 second. I have something by which I can solve this. Yeah, I have got this. 1 second, just a second, just a second. So energy will be 1 by 2 pi integration minus infinite to infinite mod of x omega square, that is a square plus 2 square t omega. It will be 2 pi into from the standard result pi by 2. This 2. Okay. So it will be 1 by 4. It will be 1 by 4. It will be 1 by 4 now. So energy we have found, and 99% of the total energy it is told. So in the if the bandwidth is b, then energy will be minus 2 pi b to 2 pi b 1 by 4 plus omega square t omega, and that is equal to minus 0.99 by 4. Here if we solve, and this is again a formula tan inverse tan inverse omega by 2. Okay. Second. Just a second, just a second, just a second. I think I can do this. Yeah, the formula is integration by omega square plus a square d omega equal to 1 by a tan inverse omega by a. Okay, this is the formula. So tan inverse 1 by 2 tan inverse omega by 2 by b equal to 0.99 by 4 1 by pi tan inverse 2 pi b by 2 equal to 0.99. Okay. One second. Here I think 1 2 will come because of this even function, so it will go here. Okay. Now tan inverse pi b equal to 0.995 by 2 pi b equal to tan 0.99 pi by 2, and in radian actually we need to calculate this, and this is in radian. Okay, so it will come 63.56. Okay. B equal to 63.56 by pi equal to 20.26 hertz. Now next question, let's move on. It's time to speed up. The energy for rectangular graph, energy is height square into width. So xt can be drawn as zero to 1. It is 2 except that it is 0. We have xt equal to 2 square into the charge into 1 equal to 4. 4 by 3 3 9, 4 by 3. 3 3 9. 1 second. 3 into 3. 4 by 3. Why it is written like this? Okay, got it. Okay, here this 3 is coming. This is the responsible for this, and then uh, this 3 is responsible for this one. See, just we are scaling. Okay, some scaling operation we are dividing on top of this ex here. So it will be 4 on top of that amplitude square, and divided by how much uh, it is t is, like how much is there in front of t. Okay, so it will be 4 by Shakti neighbor is 1 by 3, so it will be 0.333. Answer. The average bit error rate of the input of that having code decoder decoder will having decoder is 0.10. The probability that the decoder will fail to decode a received word correctly is key. So it will fail to decode only when more than one code is received code is wrong. Okay. No error and 1 bit error only we can consider as uh, no error. Okay, so up to 1 bit only we can consider. So in details I can go it later. As of not as of now I am going with this. Okay, PC equal to z0 plus p1. Wait a second, let's check this. Why only we are checking no error and one bit error? Can it vary in different problem? Okay, so here 7 is the total number of bits. Okay, 4 is the information bits, and 1 is the like can correct one error, but there are 4 bits, so 1 bit only we are correcting. So remaining there are uh, 2 and 3 is there. Okay, remaining 2 and 3 is there, that one can correct. So here as it is 1 is there, so we can correct only 1 bit. Okay, remaining we cannot correct. Okay, so as we correct up to 1 bit, then probability of correction will be 7C0 P0, means no error condition, and only one error was there, and that can be corrected by the Hamming decoder, that scenario. So only these two scenarios are there. So if you calculate this, you will get this 0.977, 0.1, 0.9 plus 6, so it will become 0.85. So probability of error will be 1 minus probability of correction, that will be 0.15. Okay, next so we need to find out the type of polarization here. So let's t equal to 0 for z equal to 0. Okay, it will be E naught x cap. Okay, so for t equal to t by 4, it will be t by 4 means it's similar to pi by 2 actually. So it will be E naught a y cap. So it is rotating in the left side so it is right-handed circular polarization because magnitudes are same. Okay, so right-handed circular polarization, like that it is. Next, okay, dielectric loss tangent of a sub substrate, real part of displacement current, imaginary part of displacement current. Okay, like that some options are there. This is A, B, C, D. Okay, so dielectric loss tangent of a substrate is real part of displacement current by imaginary part of displacement current. Okay, and this also you can write. So there is a good chat window uh, in chat GPT. Okay, GPT, like I have asked those questions to tell chat GPT. So that's all the questions, like all the doubts or concepts which I had for 2026 get EC paper. So that link I can share you, so you can just click the link and you can see in your chat GPT app those doubts. So there I have asked this question also, you can see there. So for that just pin uh, like in the comment section, just ping, and also in the description I am giving my mail ID and contact details. There you can contact me, I can share you the link. Okay, not an issue. So as of now I am moving on. at the end of the in this video also I'm planning to give that link, uh, or else I can share you through contact on only. You can connect with me in, I shall give you my Telegram ID or Gmail or WhatsApp number. There you can ping me. Okay, there I can share it. That will be good, I think. So let's move on next. So in dB these values will be 10 log base 10, uh, 1, that is 0 dB. Now this Pyqs equation is so related to antenna PTGT by 4 pi r by lambda whole square. We are in dB into PT in dB plus GT in dB plus GR in dB minus T log base 10 4 pi r by lambda minus 20 log base 10 4 pi r by lambda. Okay, now one thing is here dBm equal to 10 log base 10 thereby 1 milliwatt. So dBm to normal watt you can convert like this. So here it is given minus 90 dBm to 10. Okay, log base 10 to PR by 1 milliwatt. So from here I think we can get it like 10 to the power minus 12 omega, means watt, actually it's not omega, watt. So similarly, so PT we can get 0.01 watt. Okay, this is okay, I think. Okay, now in what I have converted it. So uh, 4 pi r by lambda whole square equal to PT G T GR by PR. Okay, so here R it will be lambda by 4 pi root under PT into GT GR by PR. Lambda equal to 0.30 by 4 pi into root under 0.01. Okay, as we have found it here, into gt and gr values are 1 and pr value is 1 into 10 to the minus 12. So from here I can get petrochemy. Also if I go with dB, then PR dB equal to minus 90 minus 30 minus 120 dB. GT in dB is GR with 0 dB. PT in dB is plus 10 minus 30 minus 20 dB. So it will become minus 120 equal to minus 20 plus 0 plus 0. 20 log base 10 4 pi r by lambda. Hmm. 4 pi r by lambda into 5 4 pi r by lambda into 5. So r equal to 0.3. Kilometer. Is 15 by 2 per meter. Answer is C. So answer C is there. Okay, let's move on. Only 1 hour approximately left. To speed up. Output voltage VO for the network. Output voltage VO for the network. Okay. So only voltage source first we are considering. Ratish. Okay. 1 K K K K. So here what can be done? Output voltage. So here first I can calculate VA PB equal to 3 volt, VB equal to 3 volt. So VAB equal to 0 volt. Okay, VAB equal to 0 volt again. Oh no, Shivai. Okay, so now this one is there. So here I can get V02 if it is V01. Similarly 1K 1K 1K, this is 1 milliampere. So as it is short, you can when 5K plus 0.5K 0.5K plus 0.5K equal to 1K. So V02 equal to 1 to 1 volt. So answer is 1 volt only. Okay. Let's move on. The Laplace transform of the sorry of the following signal. So X2 X1 is to the power minus 2s by s into s square. Actually it's the ramp function, so it is 1 by s square, so to the power minus 2s by s cube. So option C. Next, consider the following. This consider the following systems: by n equal to 5 by 6 by n minus 1 minus 1 by 6 plus xn, where xn equal to del n minus 1 by 3 del n minus 1, then yn is yn we need to find out. Yn equal to 5 by 6 minus 1 by 6 divided by minus 2 sub n. N equal to del of n minus 1 by 3 del of n minus yz equal to 5 by 6 z to the power minus 1 minus z to the power minus 2 plus okay, so up to this here y is there, so it is yz, then xn starting from here, so it is 1 minus 1 by 3 z inverse. Okay, now yz equal to 1 minus 1 by 3 z inverse by 1 minus 5 by 6 z inverse plus 1 by 6 z to the power minus 2. This is 1 by 6 z to the power minus 2. Minus 1 by 3 z inverse. 6 minus 5 z inverse plus z to the power minus 2. 6 z inverse. Okay, let's not do this. And minus 1 by 3 z inverse is 2 like this. Okay, 2 minus z inverse 3 minus z to the power minus. Okay, so by 3 z inverse plus 6 into 1 by 2 into 1 minus 1 by 2 into 3 1 minus z inverse by 3. Solution of so So this we are getting okay. It means 1 minus by 2 z inverse. So it will be in this time domain or impulse. So ion is stable and causal. Okay. Bounded input, bounded output, and causal is only depends on present and past input. Okay. Stable and causal. Stable and causal. Answer D. Okay, how the Joes kindly make your this day count for your country and Earth. Earth is not visible here, but Earth is there. Okay, next DMS digital modulated signal, a digital modulated system with an alphabet of four source symbol. Multi-level is there -1, 0, +1, +2. Signal representing a long sequence of random symbols from the above source, which is generating 10 to the power 4 symbol per second. Equivalent Nyquist bandwidth of ST is equivalent Nyquist bandwidth. What it will be? So for baseband signal, the Nyquist bandwidth will be Rs by 2. So 10 to the power 4 by 2 means 5 kilohertz. C equal to B log to 1 plus P by N naught B. This is the channel capacity formula. Two things you can remember here. Power in milliwatt equal to 10 to the power and dBm value by 10. And also the reverse I have written already in previous problem. So here power it is given minus 80 dBm, that will be T by 10, so 10 to the power minus 8 milliwatt. Okay, equal to kT by 2 and not equal to kT, and not equal to kT. To kT second, what they are doing. Okay, noise per spectral density. This is n naught, so it is in the milliwatt. If I want to write 4 by 10 to the power minus 17.4 milliwatt. So its capacity, sorry, channel capacity is 2 plus 2 5 1 1. So channel capacity equal to B equal to B. What is the B here? Why? Okay, just B we are keeping as it is. Then 1 plus is 2 5 1 1 log base 2. This will become 12B. So how this is coming? Is coming from this P. We know N naught also we know. Okay. B also it is given 10 to the power 6 Hertz. So that also you can put here. Then we will find this value actually. And this view we just keep as it is to see the options. So the right option is answer A and B. Next 35. A wireless, and the time is now 7. Okay. Wireless digital transmission scheme is using 16 QAM over a additive white Gaussian noise channel and a maximum likelihood receiver. Consider the information bit rate from source to be this much. The minimum transmission bandwidth in megahertz is. So maximum likelihood means receiver that chooses the most probable transmitted signal even with noise. So information bit is number of bits sent per second. The minimum transmission bandwidth we need to find out. Information bit rate is from the source is given. Okay. Okay, got it. So it is a bandpass QAM signal. So for this, the bandwidth is RB by log base 2m. RB is 4 into 10 to the power 6 by log base 216. 4 into 10 to the power 6 by 4, 10 to the power 6. Okay, I think it is understandable. 10 to the power 6. So minimum bandwidth is 1 megahertz. 36. Fourier series representation of xt is given as, okay, here we are shifting the time. Okay, so that time what we will get, minus infinite to infinite. N e to the power j 2 pi n t by capital T, I mean t minus t by 2. To the power minus t. Okay, e to the power minus j pi n t. Now this value is to minus 1 to the power n. So it will become and in the problem it is given this. Okay, that means so n minus 1 to the power n to minus n. Say if we take common this, mm, For n equal to even, it is 0. N equal to odd, a not equal to 0. अच्छा, n equal to even to odd, so 0 not equal to 0. That means following is correct. So option B is correct here. Correct. Option B is correct here. I'm just bypassing this question as of now. If you want to solution, you can ping me. I shall send you through Telegram or other uh, whatever contact details you will send. Okay. Now here we need to find out the value of I naught, as these are virtually short. So this V, okay, and these two are virtually short actually. So Vi equal to V, okay, that is 3 volt. Okay, I naught I need to find out, that is IV. In terms of IE, if I want to write I by eta plus 1. Now if I want to get IE, here current is 0. So it will be VE by 1. Now if I want to find VE, it will be VCC minus IC into IC into 2 minus VCE. Okay. Now here I think we need not to go, because V we know 3 by 1 K, it will be 3 milliampere. So from here only I notice 3 by 10, 0 point 0 30 micron. The binary ripple counter is an asynchronous counter. How much flip-flop is required in this case? Okay, to count 0 to 64. So mod now is then equal to 50 n. N is the number of flip-flop. Okay. So which is 65, 0 to 64. 65. So I will calculate this log raised to 65. So in to calculate this 7. 7, yeah, 26. This is the answer. Now lossless passive signal reflection coefficient. Okay, this is transmission coefficient, how much signal goes through. First one is reflection, then is transmission coefficient. Okay, reflection coefficient. Here for it is lossless, it is lossy. Passive. Passive is no power source, only absorbs or losses energy or passes signal. Percentage of power dissipated in lossy network at the intersection frequency. So here find out this one. This is the formula actually. How it is coming, if you want to know, you can comment. I can make a separate video, or I can personally message you through Telegram or other environment. This we want to find out. This factor will be not there in case of lossless, only lossy it is there. Because S1, S2 S1 1 and S2 intersect, so they are same. S11 we can find out like this: 20 log base 10 S11 equal to -4. Log base 10 S11 to the power square -4. So 1 square equal to 10 to the power -0.4 equal to 0.398. 0.398. Loss by Pi equal to 1. Loss by Pi 1 minus 2 into. Okay, this is S1 square value only this S1 once. So here we will get 20.38% if we multiply here 100. Correct. Thanks. Now Smith chart is given when point is shifted diametrically opposite on the Smith chart. Then what is the value of Z in here? Key. Wait, let me take some water. Gamma L equal to J 30 degree L equal to lambda by 4. Diameter opposite equal to lambda by 4. Diameter opposite, okay. If diameter is opposite, then it is lambda by 4. So ZL equal to ZO plus gamma L by 1 minus gamma L. 50 into 1 by 2 root 3 by 2 plus J 1 by 2 1 by 2 root 3 by 2 plus J by 2. 50 to 1 plus half root 3 by 2 actually it is cos theta plus j sin theta. Okay, theta plus j sin theta they are doing. Theta is 30 degree. Okay, so this is there. Another formula is Zin equal to ZO lol L ZL ZO lol is there. Okay, like that you can remember the formula. Then 2 pi by lambda into lambda by 4 plus JZL tan 2 pi by lambda into lambda by 4. So here we can get zero squared by ZL. We know ZL here, and Z also you know, so we can find out Zn. Okay, it will be somewhat 17.87 minus J 11.6. So here we are finding Zn with help of ZL and ZO. Another way is also there. There we can add the at 180 degree in the gamma L a reflection coefficient angle, then it will be 0.5, angle will be 30 degree plus 180 degree. Okay, okay, so it is same as 360 minus this whole thing, 0.5 angle minus 15 degree. So just that time the load is input side load. Okay, Zn equal to Z0 1 plus gamma L gamma L nu by minus gamma L nu. So this is like this, and then we'll get it same. Okay, let's move on. Now from this question I shall not solve it totally, because time is less and I want to solve all the questions, because in future I want to see this video again and again for revising also for myself, and if it can be useful for you who are watching, then I'll be very happy. And yeah, that's all I wanted to say. Now let's carry on. How the Joes. Okay, we can put the value and check. Here also this one is okay. So here we can do the integration. Y limit is 0 to 1, x limit is y to 2 minus y. So now we can solve this and you will get it 0.667. Now 45. So first here is say okay. So square by 2n, an plus 1 equal to 1 square by 2 to the power n plus 1. Limit n tends to infinite. An plus 1 by an equal to limit n tends to infinite. Plus 1 square by 2 to the power n plus 1 square by 2 to the power n tends to infinite. Plus 1 by n whole square into 1 by 2. Just 1 by 2. So it is convergent. Okay, ratio test we have done. Then one ratio test and then the next one. It just goes on. and is b dash equal to 1 plus 1 by 2 plus 1 by 2 square plus 1 by 3 cube plus 1 by uh, to the power plus 1 to the power 5 plus 1 to the power 6 like that. So is b plus 1 by 2 to the power 5. is b dash अच्छा এটা convergent হয় the infinite series. This is infinite series, so infinite equal to first value 1 minus the common ratio this one, so it is 2 only, so finite convergent. From here then we can say is b also convergent. So both are convergent. Actually option C is the right answer. 46. Here the formulas are this: dn diffusion coefficient equal to mu n bt, mobility of electron bt, Einstein's equations. Okay, so here we can get then diffusion current k dn by dx. You can put dn here. dn by dx is the concentration gradient. From there we can get this one actually. Okay. Now here early voltage concept is there, that is channel the length modulation in case of BJT. So here VA1, VA2 both will be finite. BJT2 has less slope when compared to BJT1. Slope compared to BJT1 in active region. So VA2 is finite large in compared to VA1. Okay, because here we can see this is finite large. So option B and C. Okay, now be quick. PN junction is forward bias with 2 volt. Here separations of quasi-Fermi levels. Formula is Q into applied voltage. So Q is the electron charge, applied voltage is 2 volt. So 2 electron volt. Option A is the right answer. What is the dominant transport mechanism for the current flow in Jenner breakdown? It is tunneling actually. Okay. Here Jenner breakdown. In the Jenner breakdown, the strong electric field across the thin depletion region causes quantum mechanical tunneling of the electrons from the valence band of p side to the conduction band of the n side, dominating the current flow. Okay. Now here, uh, for which of the following wavelength range the LED will not emit? This we need to find out. So LED will emit LED will not emit when that for emitted how much energy is needed, that is less than equal to band gap. Now the cutoff wavelength is 240 by Eg. Okay, so the wavelength of emitted is greater than the current wavelength. Okay, or that it's not current, that cutoff wavelength. When it is greater than the cutoff wavelength, then only light will come out. The light will come from that LED. So we need to find out this. Then we will get. I think I've crossed 9.953.846 nanometer, and which lies so we can see this can also be greater, this can also be greater, this can also be greater, but this is less than this one. So in this range only it cannot emit, it will not emit. Find the value of Ix. So here using KCL nodal, these two will get Ix value 3 milliampere, not an issue. Here using Mason gain formula, will get it 1 by s plus 4. So forward path is 1 by s plus 4, and here other path is 1 by s plus 4 minus s plus 4. This sign is very important. Because of this sign comes. Okay. So this is the answer. Here again, in short, if we want to tell is 2, here 1 and minus 2, these are lambda's values. So trace is 1 minus 2 equal to minus 1. So determinant is 1 into minus 2 equal to minus 2. So only option A is matching with this, and method 2 is we're doing like this. Okay, because of ux and because of uy. Okay, then we're performing this derivative. Okay, e to the power t e to the power minus 2 to the power minus 2t. Okay, a b c d e to the power t e to the power minus 2t. Now here we can do like this: e to the power t equal to a e to the power t plus b e to the power minus 2t. Similarly this. Okay, and from there, okay, we can get from equation 2, okay, equal to 1, equal to 0, c equal to 0, equal to minus 2. Okay, okay, okay. Okay, I think you will get it. 54. Okay, there are 100, highest score is 100 here, and the fourth highest score is 76. The maximum difference among them is 24, and here 24 is less than 25. So in an